For this problem, we're going to take a look at question number 25 on page 384. So let me write this down. 384, number 25. The problem gives us two random variables. We're told that the expected value of x, also known as the mean, is 10 with a standard deviation of 2. So the standard deviation of x is 2. Right away, I turn that into a variance as well. So the variance of x is 2 squared, which is 4. The other random variable is y. Y has an expected value of 20 with a standard deviation of 5, which means the variance of y is the standard deviation to the second power, which is 25. Part A asks us to combine the variables. Well, actually, A is the expected value of 3x. We're not quite combining them yet, but the expected value of 3 times x. The rules concerning multiplication by a constant say that for expected value, we can simply pull the constant out, and so we'll have 3 times the expected value of x. We know the expected value of x is 10, so it's simply 3 times 10, which is 30. It's probably fairly intuitive for most people. The standard deviation might be a little bit trickier because we're going to have to start with variance. So the variance of 3x, or the rule is not intuitive. The rule says here that once again the 3 is pulled out, but it has to be squared. So it becomes 3 squared times the variance of x. So we have 9 times the variance of x is 4. So there we have 36. We don't want to stop here because we really want the standard deviation. So in order to get the standard deviation of 3x, we take the square root of the variance, the square root of 36, which is 6. So the answer for this particular problem has the expected value of 30 with a standard deviation of 6. So that is part A. We move on to part, let me label this, we move on to part B. B wants us to find the expected value of y plus 6. Again, this one's going to be intuitive for the expected value, but a little less intuitive for the standard deviation. The rule here for expected value says we can simply do the expected value of y and then add 6 to whatever we have. The expected value of y is 20, so we simply have 20 plus 6, which is 26. Once again, we start with variance in order to find standard deviation. So we're looking for the variance of y plus 6. But the rule that we discussed in class is a little strange here. Adding constants to these random variables do not change their spread. So the variance of y plus 6 is simply the same as the variance of y, which is 25. So therefore, the standard deviation of y plus 6 is the same thing as the standard deviation of y, the square root of 25, which is 5. So our answer here is we have an expected value of 26 and a standard deviation of 5. Move on to part C. C is the first problem where we are actually combining the two variables. We want to find the expected value of x plus y. The rule here is we simply split up the random variables, the expected value of x plus the expected value of y. Both of these values are given. That's 10 plus 20. So the expected value of x plus y is 30. Variance isn't actually going to be very different in this one. We're going to find the variance of x plus y. The reason we always work with variance is because the rules seem to work a little bit nicer. So we'll have the variance of x plus the variance of y. Both of these values are given. It'll be 4 plus 25, which is 29. And therefore, to find the standard deviation of x plus y, we'll take the square root of 29. Off the top of my head, that's probably around 5.3 or something like that. So our answers here are the expected value is 30 with a standard deviation of 5.3 or so. All right, we move on to D. D will be the same thing as C, only instead of adding the two variables, we're going to be subtracting them. So D is the expected value of x minus y. Sorry about the keyboard. There we go. So we've got the expected value of x minus the expected value of y. The rule is very intuitive here. So the expected value of x was 10. The expected value of y was 20. So 10 minus 20 is negative 10. We go back to variance. In variance, we have an interesting result here. We never subtract variances. So the variance of x minus y is the variance of x plus the variance of y. And so you're going to see the result for part D is going to be exactly the same as what we got in part C up here. So our result will be that the variance is 29, which means the standard deviation of x minus y is the square root of 29, which I estimated to be about 5.3. So we have an expected value of negative 10 with a standard deviation of 5.3. But notice how we did not subtract variances here. We get to our last problem, part E. We're trying to find the expected value of x1 plus x2. x1 plus x2. The little numbers next to the random variables here are simply to show us that these are two different occurrences of the random phenomenon, not just the doubling of one. So the rules here are we break apart these two. So the expected value of x1 plus the expected value of x2. The expected value of x both times is 10, so 10 plus 10 will be 20. Variance is going to work the same way as it did in parts C and D. The variance of x1 plus x2 is equal to the variance of them separated. The variance of x we already worked out is 25, so we have 25 plus 25, which is 50. To turn this back into a standard deviation, we've got to take the square root of 50. So x1 plus standard deviation is the square root of 50, which is 7.1. So the answers for part E are the expected value is 20, and the standard deviation is 7.1. Let me scroll down here to show our answers one last time. So if you want to pause the video as you're doing the other problems. Good luck.